So parting was quite successful, well, semi-successful anyway. These two here, you see the galling there? Yep, that's where it bit in. When it bites in and you run in carbide, that's what you get. So I changed to a high-speed steel tool because, well, there was no more ends left on that after I'd snapped both doing these washers. And the high-speed steels did the rest of them. Not a problem. Parted all of those off, I parted everything off. But I did get quite excited. Very, very excited. And made a balls up. The washers are the same size as the spigots. So those washers are very nice, 3mm 10mm washers for some other project, just not for this one. By the time I'd realised I'd only got enough material to make one proper sized washer, so I've just ordered some 2.5mm washers. Yep, and that one nearly snapped. That was the last one. I was getting a bit aggressive with that one. Obviously I just realised I'd made a big balls up. Anyway, here's the setup. So you can see there's a spigot, a washer and a bearing. That's a wheel. Each one of those will be probably nut and bolted into the four corners of one of those. I have two of those. That'll be the front dollies. And there is the rear dollies for machine moving. Now, if I just rest the machine on that, it's going to slip off. So I'm going to bond some rubber to them and bond some rubber to those. So I've got some offcuts. I got all of those, which are just offcut weird sizes, which don't exactly fit anything, but they're good enough for me. For this particular, probably only used 3 or 4 times. Hey, up, it's going to go for it. It's going. It's going. Caught it. Anyway, the point was I got all of those for the same price. If I'd have had them professionally cut to the right dimension, the same price as just 2. So, you know, quite happy that bloke keeps his offcuts and sells them at weird prices. Then underneath it you can see these weird shaped things with really rough painting. Well, that's not really rough painting, that is die-cam blowing, metal blowing marking compound. And you can see the shape that they are because the metal blowing compound highlights it nicely. And you can see the sheet underneath it of 2mm steel. This one here is identical to the one I just cut them out of. And when I was getting them, I thought, you know, if you just get one sheet, you know you're going to run out and you're going to need 2. So I bought 2, and I didn't need that much for this, which is the 2 drawers. These are the drawers for the unit here, the milling unit. But I do need some shuttering for around the back here. So on the back here there's going to be a solid non-see-through section which is a chip shield, and it's going to direct the coolant and oils into the thing that I'm making. I don't know what it's like yet. Oh yeah, oh, I've done the lead screw. I don't know where the old lead screw is. It's around here somewhere. Ah, I've got it. Okay, so I've made the lead screw. I should have videoed that really, but I didn't. I was in a rush. So I've got the left hand thread and I've made a longer lead screw for the rear. And it is that much longer. A lot longer. A lot longer. And I got some more goodies for this. I know I'm going to get absolutely knocked off winding this handle now, especially because this has never travelled as far as it did before, so it's a little bit tight at this end and a little bit tight at the top here. Yes, it needs scraping. No, I'm not doing it right now. Anyhow, I've got a NEMA 34 motor to do the turning that I'm doing here. Hopefully with 12 Newton meters of torque it will do it, although it is quite stiff and I'm not quite sure whether it will or not. I might have to gear it down, but I have it anyway. It is a NEMA 34, it will go up there. So I have NEMA 34, a stepper motor driver and a power supply unit for it. If that isn't powerful enough I'll be surprised, but it might not be. So the plan of action up here will be drilling and tapping 4 or 6 holes in this thin casting here M4, which is 4mm, and then having a plate, a steel plate, probably a 10mm steel plate, which will encompass the NEMA 34 sitting up here and bolting to it. So it will be up here somewhere, the NEMA 34, because it's quite a big motor. It's a long one. It's a closed loop stepper motor as well, which means it's got less torque but more speed, so I might have to gear it down anyway, which is probably best because it's better than one of those one-to-one couplers on it. Anyway, NEMA 34. So I'm looking at CNC controllers. I can just make a simple duty cycler myself and then have it so every click is 2 steps or 4 steps or whatever. I can do that, but I thought, well, I might as well get a simple CNC thing set up on it, whereas I'll have to have a computer running, okay, but I'll just press the up and down button and it will go up and down. Don't know yet. I'm looking into it because this is going to be CNC'd anyway, so I might as well just bite the bullet and buy the other motors and just do it now. Anyhow, oh, and I made a bell end T-slot scraper way before double boosted. I've had it for years and years, and it looks like a bell end. It is. It's a bell end T-scraper. If you want one, just make it. It's dead easy. Right then. Okay, so what I did with this was I've marked these out, and fingers crossed, if I can find a ruler, yes I can. Fingers crossed, I have undercut them or cut them too small. Yes, I think you'll agree with me, that is not quite 190, well, that needs to be 191, and that is not quite 190, and that needs to be 190. So I have got metal to trim off in here and in here. I did my calculations earlier on, that's what I need. Blah blah blah, 500 plus 190 plus 190 equals 880, and 436 plus 191 plus 191 equals 818. I might have gone a little bit too much on it, but we will find out. These are going to be 436 wide, these drawers, and they're going to be 190 deep, I think you've guessed. Quite deep drawers. So I am thinking about putting some kind of stacking system inside them. I don't want any more drawers, and deep drawers are good for stuff like rotary tables and things like that, which you might not need because it's going to be CNC. But there you go. There will be drill storage, storage there. And 190 is good for storing drills. You know how tall drills are. So, I mean, this is just a cheap drill pack, but you know, there you go. Them standing up is just a lot better than laying down. And the bench is ready to come out. Ready to come out. The shaper is ready to go. So many things are happening at the same time. But now I have them. I've ordered the washers, them ready. I'm just going to stick these in the Bridgeport over there. I'm just trimming the vise in at the moment. And I will square these up, put the 4 holes in, make them look a lot better, paint them and glue the pads to them, and then glue the pads to these, and then there will be finally some machine moving, and then there will be some concrete hardening happening. It's been a long time for me waiting for this machine moving to happen, and hopefully it's going to be smooth sailing. There is one major drawback though. The winch that I was going to use is now attached to the wind turbine unit, and it's so hard to fit up there I don't want to take it down, so I might just go ahead and order another winch for in here. Or I've got a 12 volt winch which needs brushes in, and the brushes I've got don't fit, so I'll have to shape them, so I might do that. But I think it's going to be best to have these sort of strapped to it and then winch on these and pull it. So yeah, I think that's going to be the best way of doing it. So that's what I'm going to do anyway. Oh yeah, and the step isn't too aggressive here. The step isn't too aggressive. There is a bulge just there which I'm going to have to hammer out. No, I'm not. I'm putting epoxy down. Awesome. It's going to be level as well after it's hardened. Look at the amount of dust. Let's get in close to show you the dust. It's just dust everywhere. You can sweep as much as you like. You can get water in here and wash it out. 2 days later, there's just dust everywhere. And what I noticed was, I was in here one day, and if you're sitting here quietly, you can hear the concrete goes, and a bit of dust comes out of it. It's like it explodes. It's like a little volcano comes out of it. That's where all the dust comes from in here. I saw it happen. There's probably something wrong with the concrete, more than likely. That's why it's doing that. But it's going to have a lot of hardener tipped on it very shortly. Oh yeah. I think it's a good idea. It's a good idea that I used rebar all inside that cavity wall and filled it with concrete. And the concrete that I mixed, and I know the concrete that I mixed doesn't explode like that. This stuff was bought from a concrete supplier which came around with a great big concrete truck. Right, so there's me. I'm going to sneeze. Sneeze. I'm going to sneeze. Yeah, baby, that's COVID. Right, so I've got my steel cut out and I've shaved it off with the angle grinder to perfection. And this is my bending jig. I was just about to buy a £760 bender from Machine Marked, which is a bit like a Harbour Freight. And then I read the specifications on it, and it can shear 1mm steel up to 760mm long, and it can roll 1mm steel to a tube of a 38mm external diameter, and it can bend 1mm steel 760mm long. This is 2mm steel, so I didn't bother buying it. So this is the new setup of death. First, on the first one it was easier because I didn't have a great big 190mm piece of steel sticking up, which is the side of the drawer. I climb up on the table. Now, to climb up on the table without it falling over, I have to put down the steadying feet and put the second steady rest in to make sure it takes my weight. I was just running it as it was with no steadies in at all, and I've been doing that for weeks. It's perfectly stable just on the casters, but I thought if I'm on it I want to be down, so I've put in the 3 feet. They are in. It is stable. Put 2 stays in, so now it is rock solid. Look, there's nothing moving at all on it. It's rock solid. Okay, so when I get on it, all that noise happens and I start worrying what's happening, but not to worry. Then I will pull it up as far as I can get it until these start touching here, and they do. Then I will readjust them back about 1 centimetre, and then I'll bend it up as far as I can get it in. After I've done that, then I'll take this piece of steel off and I'll put the ratchet strap on from the side of the table up to where the lip is, and I'll bend the lip back until it's gone over 90 degrees, and then I'll use the lump hammer to go down the edge. And obviously there's a few pummeling marks at the bottom there, just a few, but it's not bad. I wouldn't say that's particularly bad, although I've got a drill and tap in that kind of area. Not to worry, it will be okay. And the inside, I get a tighter bend on the outsides than that I do in the centre, but not a lot. and there is no significant amount of flex in it, so I'm quite happy with that. Obviously I'm going to have to come up with a new cunning plan to do the last two folds. This is going to be entertaining. So you've got the toilet view in the background and the temporary door and the, what else can we see? Oh yeah, I can see the water butt, the temporary water butt stopping me being flooded in here, and the temporary wall and a propane bottle. Temperature is 14 degrees. Move that out of the way, get rid of some of this dust, move that out of the way, and here we go. It's 2mm steel, 500mm long, and I can assure you it doesn't want to bend. No, it doesn't. And this is sharp, and I need to get rid of somewhere. This is not easy at all. Right, so I don't want to get that jammed up in my jack, see? But I need to be over here to try and do it. No, I ain't going to do it. Because this is, I don't know how I'm going to do this. I really don't. Put that, put it there like that. I'll put that, it's going to be phone in the pocket. Maybe this will work. Maybe. Pull, boy, pull. Hamstring hurting. Everything's hurting. Lifting way too much stuff around. No, I can't get out of the way. No way there. Go this way. This way. Right. How much hurting is this hamstring going to give me? Not as much. Man, is it hurting. Just if I had some strings or something. Right, come on. Can we get here? Can I get on it? It is tight, I assure you. I might be able to start it off. I might have to start it off down there, although I might not be able to. Yeah, I can. That's as far as I can go, because it's metal on metal. And although the table's very heavy, it slips when it's on metal. Because it's on the other tabletop, which is on the floor. Should be able to go a bit further. I might run past the legal point now. Oh, my word. Here we go. Right. Yeah. We're getting there. Pull the G-clamps back a little bit because they're fouling. Warning, this next bit is really noisy. That's what we'll have to do for the time being. How did that get a downward thing there? We got it. Is it vertical? No, not quite here. That's better than the first one. Maybe what a bit of practice does for you, don't I? Now this is the design for the bender. Just quickly go through it. So there is a piece of this steel here, vertically mounted. Off it there's another piece of steel, just there, and another piece of steel, just there, and a pin in between them two. One there, one there, one there, one there. Pins. And then the rail, which is this unit just here, the rail will have two holes drilled through it and some springy actions to keep it up in the up position. The end of the rail will have a cutout on it which will be semicircular, and the bars will be drilled and have pins sticking out for the lever arm, and the lever arm will act on those round bits at the outside, and the lever arm will be keyed together. Both of them will work together. Then there'll be individual fingers with grub screws holding them in, and a V-block bolted to the upright, and then probably some kind of plinth at the bottom for holding it to the table, so I can G-clamp it down. That was the idea, and I thought to myself, when I looked at that and I thought about how long that's going to take to make to get a perfect bend, I thought, well, that's 3 weeks, 4 weeks worth of work for me. That's 2 hours worth of work, and it don't look that bad. The only problem I'm going to have is this one here, so I might have to make some custom clamps for that, because I'm thinking line that up like that. Yeah, line that up like that, and grab some steel up there. I've got some 8mm steel up there somewhere, or some box section, 25mm box section, might put that in it, and cut the piece to length, exactly to length. If I'm going through that hassle, I might make it triangular. I've got to do something here. I would like this front surface to be nicer. So you may notice the long bar here is shorter than it was. It is, and that's because part of it is in there. See it at the bottom? The setup in there was like this. That bar was across the scribe line, butt up against it right on the scribe line. And then I have these two things here. These are the skates for the machine movers, which are very nearly finished now. And then I have this 40B, whatever it is, centimetre bar clamped down with two sash clamps across it. And then I had that piece of 60x20 clamped underneath it like I did before, and used the two grips and bent it up as far as I could, and that wasn't a lot, but it did make a nice crease, a really straight crease. Let me see how straight the crease is down there. And then I spun the whole thing, well, I pulled, no, you can see I just clamped it in there basically. So I've moved the bar was, oh, I'm too close now. The bar was on the raised section, and I've pulled it out onto the front section. Or should I say the bar was on the base and now it's on the front, or the back, whatever it's going to be. And then I have lifted it from there. I've just pulled it towards me as far as I can go, and it's flexed back that far. It's now touching the clamps when I pull it to its fullest extent. It will not bend anymore. I don't have clamps which are 180mm. Now clearly if I'd have made 4 drawers at half the length, I'd have just bent them straight over now. Just as it is. But I can't. So, I was going to do the 45-degree thing that I was talking about. That isn't going to happen. It's just the clamping arrangement. I can't clamp it, so what's the point in going through all that hassle? So I thought I'll get a piece of bar which is the right length to fit inside there, and I'll see what I can do. So I've got there, and the only thing I can think of now is to pop 2 holes in it, and 2 holes in my welding table. So pop 2 holes in there, and then use them as a drill guide and put 2 holes in the welding table. And have some kind of alignment thing here, maybe a clamp with a bolt in it, so I'll know where to go to when I'm doing this the second time. I've got a few new additions, but this is one to note. Got given this. Do like having little presents like this. This was seized up, solid, had bits missing. I've had to make this collar to stop the handle from falling out. It's not as smooth as I'd like, but it was red with rust, this whole thing. I've dusted off the end with an end mill, both sides. That's just a little pressing thing I made for it. This was just a solid lump of rust, so I'll give that a good going over. The paint wasn't shiny as it is now, and I put these brass shims in to make it run smoother. It's a 1/2 ton Clarke strong arm arbor press. I've already used it for pressing the bearings in on me grinder, which seems to be a repair project about every time I use it. So that's that. I'll repair the base of that little hand grinder, and then it breaks again. Not to worry. It gives me something to do when I haven't got a lot to do. So I just don't seem to have much to do I? Anyway, as you can see, one of the drawers has been bent, and the holes I mentioned are drilled in the areas. So I'm going to show you how I heave and hoe to get them bent into that position. And yes, it does fit in between there quite nicely, that one. So next, set you up, I'll show you the heaving and hoeing and the bending of that. So 2 holes drilled in probably the front of the drawer, line up with the 2 holes drilled in the table. And now my ball with my two M6 hold down bars, hold down kit, studs in, go in there. I don't like fiddling, so I'll just hit them with a hammer a little bit and they go in. Seeing as the end rails on my table are not solid, they are box section. So that's some M6 nuts, they're 10 mils across, that would be equivalent to a 1/4 inch bolt and a 3/8 spanner, to give you an idea of what kind of clamping force I'm going to be using on this. I'm tightening these up into a FT. And there's 2 types of FT in the car trade. There's one fairly tight and the other one's got square wear in front of it. And for M6 these have got square wear in front of them. Otherwise I am stretching them. I've gone past the point of what a M6 should be tightened. And there's some mating calls going on outside at the moment. Now look, there's some blokes yawping. And for the first initial bend, I'm putting a G-clamp on either side, just give it some extra oomph. But very shortly there'll be some interference. So here we go. I'm set up for the bend. Oh, you beauty. Yeah. And that first bit, the whole drawer is trying to go one way or another. Once you get a bit of crease into it, it becomes a little bit easier. There we go. One end done. Difficult. Oh yeah. Once you get past that initial crease, I wouldn't say it's easy, but it's a lot easier. There we go. 2 drawer shells. Just about how I want them. Ta-da! Done. Right, let's have a look at that. So I've got these 2 holes. Obviously there'll be 2 holes at the back, which is not desirable, but I had to bend it. And clearly the side here is overbent, and I'll use some trolley go on, think about it, bottle jacks, there we go, to straighten them out for a start. And then, after I've got them straightened out, I want them 90 degrees on, then I'm going to use the sash clamps, as you can see down there, I think, There you go, 2 sash clamps there. Use 2 of those on each drawer, and I'll cramp the outsides in until they're 90 degrees. Then I'm going to get some spot welds down it. So I'm going to set up for that now. I think I'm going to get a TIG welder out and start doing some TIG. And after they're done, then I've got this sheet of 2mm here, and I've got to make the back plate for the milling machine. It's going to be like a spine for the back of it. It's going to have 2 bends in it, so it's going to be flat for around about a foot, and then a foot of it will be bent around about 15 degrees, and another foot will be bent at 15 degrees the opposite side, and that will be attached to the back somehow. And then this piece of steel here that you can see down here, you can see that, it goes from there all the way up there and then finishes just there. Well, that's a piece of box section, and that is the same box section that the frame for the mini mill is made out of, and that is going to go just inside the back splash, just here, up here, and then the NEMA 34 mount, which will be a steel plate, 10mm steel plate, which will come out here somewhere, will grab onto that, and that will offer it some more rigidity in the flexible forward and backward bit there. So that will make the column twice as stiff, basically, I should imagine. And that's the next precision bit going on this bit. All this stuff is just fun, as precise as possible, within 1/4 millimetre. And they are amazingly, I can't believe they're within 1/4 millimetre of each other, width-wise. Length-wise doesn't matter with those. And after I've cut the back splash out, then the hinge sections are going on, and I think I've shown them before. They're the 2 hinge sections which will be welded on or bolted on here, and then the whole fold-in section, so it can tuck away, will be put on, and all of the coolant drainage system will be made out of this 2mm and what's left of this 2mm. I think the folding sections will probably be plastic, but I don't know yet. It's getting a bit heavy now, so I don't want to make it too heavy. Oh yeah, I've got to make another box out of this, similar to these, to go down the bottom to hold the coolant as a coolant tank, or I've got to seal that tube work up and all that and make the actual base of it a coolant tank. I did some pulling, I did some pressing, I did some clamping, I did some welding, and I've now done some grinding. And after all that, these 2 boxes are almost identical. I do not believe it. They are very close to one another. Extremely close. Now the fronts are square, but the rears are identically stupid. I don't know if you can see that. I don't know how I did that, but I did it. So they're like a butterfly. I think you've got around about 1/2 millimetre from there to there, and that is 1/2 millimetre less than from there to there, and from there to there. The rest of it is pretty square. I don't know how the back end didn't become square. Now, this is probably where it is. You can see there's a little bit there and a little bit there. So the marking out went a little bit away there. That's okay, because the fronts are square to the sides. The backs are not square. They're quite a way off. Right, so I have a different jumper on. The other one is full of grinding rust. It is being washed. Sorry, no advertising today. I have straightened up the drawers. Yeah. And now all that's left to do is to fit it. So I trimmed off these pieces. With the 1mm disc. 2.5 1mm discs. And then tied it up with a 120 grit flat disc. I haven't really thought about this, have I? I could have set this up a bit better. Oh well, let's just go for it. We'll put one screw in the end there. These are stainless, so they're not magnetic. And you've got the wrong bit in. Immense. So, just go for it basically. Basically, it's going to drop, something's going to happen, undoubtedly. There. That should be going in now. See if we get the second one started. Oh, that's two started. So we get the third one started. Without dropping anything, this might be more difficult. Might be, it is. It's impossible. I can't do it, Captain. There we go, I've got it. There we got it now. I'll drop the screw, will be fine. Right. This is started. There's a lot of huffing and puffing going on. First fit up. Got quite cross-threaded now. Yep. That's going to be a problem. I'll just drop the bit. It's badly right underneath in the hardest place to get to. There we go. Right by the wheel. Hopefully that's just the screw that's broken. If not, plan B will be nut and bolt. Well, there isn't a lot of bolt sticking through from nut and bolt on it. Not happy. Not happy at all. I don't know how I get a bolt started here, but maybe because I put it in the wrong hole. This is the wrong hole. Wrong hole. Anyway, I've got some. I've got a screw. Let me show you. There we go. So I'm quite happy. They work quite well. I've put the drawer in on the wrong hole, but not to worry, that can be sorted out. And the screw on this side, if you'll better see it, there. It isn't all the way in because it's rounded or something. I've got to get some long nose mole whips in there or something to go and rip that out. I've put these in on the adjuster holes, and I believe they were supposed to be on the solid holes, so I've just got to put this drawer back in. Smooth. Should be able to put plenty of weight in those drawers. They are in, basically. Some slight minor adjustments required, nothing too much, and yeah, they're good. They're in. I had drawers. It has drawers. Immense. So I've got a few teething problems to sort out, and the drawers will be in. So I've done some temporary shields. Well, they're not done, but to give me the idea, they are not anywhere near secure. But that'll do. I've used the old shields off of the old mill. It's looking a bit more space on the bench there now. And the drawers are lined up. Work absolutely beautifully. Already started filling them up. And I've drilled a hole in here. We're getting some drips down the floor, and the drips do emanate from the centre because it's angled that way and it's angled down that way to the centre point here, and the whole machine slopes forwards. These are thicker at the front, they're thinner at the rear, and then the pads underneath are the opposite, so the whole metal shield here tilts forward. So this bit of oil which is creeping around here now will eventually make it down here, and now hopefully into the hole and then into the temporary oil collection. So there we go. And I've been marking out on that sheet of metal for the front shield here, which is going to be 4 centimetres. The side centimetre shields. The side shields are going to be 12 centimetres either side, and they're going to have an angle put on them, and they're going to be drilled and tapped in to the plate here with a row of those 4mm stainless, probably 1, 2, 3, 4, so another 16 of those stainless steel screws holding those primary shields on. Then there will be a brass gauze from this shield here up to here and angled down here, and that will keep all the chips out of the drain hole here. I'm going to get the die grinder and make this more acceptant of the oil and the coolant, and this will probably be drilled out to, at the moment it's 1/8 inch BSP, and I'll more than likely drill that out to 1/2 inch BSP or maybe even bigger, because when it's running coolant it needs to get a good amount of drainage. these shields will be angled up slightly to allow the coolant to go back in again. Then the folding shields and what have you, they'll be around the outside of that. It'll be pretty much like this. The rear shield, the main shield, will be bolted straight to the back and straight up. It's going to be the width of this. I've decided now, finalised the decision. So it's going to be exactly that width, and the height up here somewhere, up to around about level with the top of the column, I should imagine. That's going to be that, and that will just be bolted straight into the back here and go straight up. And then that column that I'm on about for stiffening the column up is going to be bolted to this plate. So I've got to make some kind of adapter plate which fits into this, shape it nicely so it conforms, bolt all that up, weld it, tack weld it in, and there's loads to do on it. That it is working now, so I wanted some shields to stop the chips going everywhere. So the next time you'll see it, this piece of wood here will be level with that piece of wood. It will deck down onto this flush, and then I'll have these are the original side bits which clipped on to the metal clips here, and I may use them because they'll come out to about here, or I may make some new ones just because the wood takes around about 2 hours to put a temporary bodge on, and the steel takes ages. But saying that, I may slice the steel off of this, which is the proper steel backsplash, because that will just make things a lot easier. And once I've done that, I'll probably just make the other ones anyway. But I've got to stop chips going into the drawers now. We're going to be starting to use the drawers, and I want the coolant collection to be good. There's probably going to be 2 coolant collections, one oil and one water, or soluble oil, and one just for normal oil. But it is close, it is getting done, and the drawers, they work, and well, they're not perfectly aligned with each other, but they're not bad. I'm not disappointed at all. I think at the end of the day, once all the side sheeting's put on with the tank and everything to cover it all up so it's all boxed in, at that point then I will probably put some face plates on the drawers to make them look absolutely perfect. A bit like you would on a wooden drawer. In fact, I might make wooden front covers for them. But yeah, it's going to be all boxed in eventually. Even the base will be boxed in. Apart from a recess at the front here where your feet will go, so there'll be this bit here won't be boxed in, but the rest will be boxed in. Done for today.